Hey guys, welcome to the channel. In this video, we would be going through the low-level design of the Snakes and Ladders game and how to implement it in the Rust programming language. These are the requirements. The game can have any number of players. Each player gets a turn in rotation. That is, the player's turn comes after all the other players have played. There can be any number of dice. Player moves X steps forward if he rolls an X on the dice. That is, if he gets a 2, he moves 2 steps forward. If he gets a 6, he moves 6 and so on. If the player reaches a cell which has a ladder, he goes up the ladder. Similarly, if the player reaches a cell which has a snake on it, he goes down to the tail of the snake. Player should exactly reach the last cell to win. He cannot overshoot it. The first entity we have is snake. It only has 2 fields, the start and the end position. The start is the snake head and the end is the snake tail. When you reach a snake head, you move down in position, so the end should be less than the start position. The code is pretty straightforward. We create the snake struct representing the entity. To create a new snake, we have a validation to ensure that the start should be greater than the end. If it isn't, we throw an error. Ladder is very similar to the snake. The main difference here is that the end position is greater than the start, since we move up the ladder from bottom to top. In the code, we have accordingly added the validation here as well. Why do we have separate entities for snakes and ladders? Conceptually, they are both very different. Snakes and ladders mean different things. Both of them can grow independently and can have different validations. For a new team member, clearly mentioning that the entities mean snake and ladder helps the person understand the code better. Code clarity and ease of understanding is much more important than dry, which is do not repeat yourself. Code is written only once, but multiple people have to read it and understand it as long as the software exists. So by clearly naming your entities correctly, you can make the lives of your teammates much easier. We have players in the game. Each player has a name and a corresponding ID which uniquely identifies the player. When creating a new player, we increment the max ID and assign the new ID to the player. That way, each player gets a unique ID. This code isn't thread safe. We haven't taken an explicit lock on the max ID because there isn't any case where this is called in parallel. However, in any production software, you should have a locking mechanism in place. The requirements mentioned that we can have any number of dice. We define this number in the count field. In the roll method, we generate a random number between 1 and 6 for each of the die and add them up. The 1 to 7 signifies that we generate a number greater than or equal to 1 but less than 7. The board is responsible for maintaining the cells and the objects on each cell. Cells is a 2D grid. We have a custom board size. In this image, it's a 6x6 board. We have 2 maps, one for the snake and one for the ladder position. The key is their start position on the board. So if the player reaches that position, he either moves up the ladder or gets eaten by the snake. We also maintain the position of each player on the board. The key is the player ID. and the value is the player's position on the board. We have two ways of storing the player position. We have gone ahead and stored it in the board entity. The reason is that the player is an independent entity and isn't aware of the board or game. The player, in fact, can be part of multiple games, whereas each game has its own board, so it makes sense to store the player position there. Board has a new method which acts as a constructor. We need the snake and ladder positions along with the list of players to initialize the board. All players will start at the first cell. Refresh cells for display is implemented just so that we can print the position of the snakes, the ladders, and the players in a more readable way. This is just so that I can demo the game better, and you won't actually need to implement this in an actual interview. Position to cell converts the integer position on the board to the cell on the 2D board. Display is again mainly just for printing. This is how we are maintaining the game manager. It has the board, the list of players playing, which are maintained using a deck. We are using the deck to change the players' turns more easily, as you shall see later on. We also have the game status, if the game has started or completed. And finally, we have the dice used in the game. In the game loop, we first need to get the player's current position. Then that player will roll the dice. Based on what number is shown on the dice, the player moves forward. We check if the player has won, and if that is the case, the game ends there. If not, we check if the player has reached the start of the snake or the ladder. If yes, he moves up the ladder or down the snake. Once that is done, now it's the next player's turn, and the loop goes on until one of them wins the game. To get the player's current position, we get the ID of the player whose turn it is, that is, the player at the front of the deck. We have the player positions map in the board, which gives us the player position. Since it's a hash map, we have to check if the player exists or not in the map. But if you haven't done anything too fancy, the player should always exist. Next, we roll the die, which is simply calling the roll method of the dice struct. There was a requirement at the start that the player cannot cross the final cell, and in order to win, he has to reach exactly the last cell. That is what we are validating here. Check if the player has won is simply checking if the position is equal to the value of the last cell. This is the code to make the player jump up or down if the new position contains a snake or a ladder. Finally, we insert the player into the new position and change the player turn. Changing player turn logic is similar to the one in the tic-tac-toe video. You can check that out to understand it better. Here is the entire code of the game manager file, in case you're stuck implementing it somewhere. Both player 1 and player 2 start here. So first roll is by player 1 and he gets a 3. So both of them are here initially. John gets a 3, so 1, 2, 3. 3 is of course a ladder. So from here he will reach here. So as you can see, after the turn, player 1 reaches here. So the ladder seems to be working. Again, player 2 gets a 1. So from here he moves here. From here, player 1 gets a 5. So 1, 2, 3, 4, 5. So he reaches here. Similarly, the game keeps on going on. So if you see here, player 2 gets a 4. So 1, 2, 3, 4. Now player 1 gets a 6. So from here, in order to win, player 1 needs a 1, 2, 3. So he will have to keep rolling until he gets exactly a 3. If he gets a number greater than 3, it's the next player's chance. So then Sam gets a 4. He was here, so 1, 2, 3, 4. And player 1 gets a 1. He can move ahead if he gets any number less than or equal to 3. But yeah, finally he has to reach here. Again, player 1 gets a 6. So from here, he needs a 2, not a 6. Finally, both player 1 and player 2 are here. Since player 2 gets a 2, he reaches here. And both of them need a 2 to win or a 1 to move one place forward. Here they keep getting a number greater than 2. Finally, player 1 gets a 2. And he wins.